Continuing on with Chapter 3, we're looking at applications of derivatives. We're going to spend a little time talking about Newton's method. Again, this is something that you will probably almost never do unless you're getting into writing computer programs to do some stuff. If you ever wondered, how does the graphing calculator find find a zero of a function? And why do you have to give it an interval? Give it a value to the left, a value to the right, and then guess at a point. You're going to kind of see that when we look at Newton's method. So just as this is kind of just to show you another example where this is used, we don't use it because we have our technology program to do this, but this is the basic idea here. So it's basically a systematic way. It's a guess and check method where we start with an interval that one end is positive and one end is negative. Intermediate value theorem says if you're continuous and you have, that every value between the two endpoints has to occur someplace. So if one is negative, one is positive, then zeros between those two endpoints, there has to be a zero. So that's kind of where we're starting. So we start to an interval, we make a guess, and then we use the derivative, find the slope, and make a linear approximation, and use that to approximate our zero. And then we just keep going through with this process until we get a good answer, right? Makes a little bit more sense when we actually do one of those. So let's look at this. This is based on the idea that we want to find the zero of this function, and we say when you're looking around here, this looks pretty much like a straight line. Well, all lines are straight, right? This looks pretty straight. So that idea of approximating it with a line is not that crazy. So we're going to start on our interval 1 to 5, because on 1 we're positive, 5 we're going to be negative, so we know there has to be a zero between those. And then we just guess any number. We're guessing 2, which is a bad guess looking at the graph, but maybe I don't have the graph, right? The idea is if I have a graph, I can approximate it pretty well here. But we're using the graph to show what's going on here. So we first guess 2. What we're going to approximate a line. We need the slope of the tangent line. So we need the first derivative, which is 0.35x squared minus 2x plus 1.125. Easy enough to do. Now with that, we're going to find f of 2 and f prime of 2. Because now we know a point and we know a slope, we can write the equation of the line. So it's the point, 2.5, minus or plus the slope, negative 1.25, times x minus my 2. That's my linear approximation. If we graph that line, you see at 2, it is tangent at the curve at the point x equals 2. And we can use that equation to approximate where my 0 is. So I plug y equals 0, I solve that for x. Oops, and I go off to the next page. So let's let that. When you solve that, you get x equals 4, which we can see from this graph. That looks reasonable. But now here's this systematic approach. We get 4. Now we're going to say, well, 4 is now our guess. So we're going to repeat the process with 4. I already have f and f prime, so I just need to plug 4 into the equation. Get my new tangent line. And you notice now at 4, this tangent line is even closer to the actual 0. At that, that's going to give me an approximation of 3.67 if we set this equal to 0 and solve. Again, a linear equation. Piece of cake to solve. basically, that's the idea. We just keep doing this and doing this until we get close enough. So it's a very repetitive process, but it's not too hard if you can find the first derivative. Now here, I'm going to do this generally. If we just say, here's my equation, is some f of x1 plus the derivative at x1 times x minus x1, set this equal to 0 and solve it. We're going to solve this equation because now this gives me a formula. I take my x value minus, don't do that, minus the function divided by the derivative at that value, and that is my new x, my x2. So, kind of sum this up. We're working through trying to describe what's going on, but in reality, we use this formula to help us out. So we don't have to, write the equation, plug in and solve it. We've solved every single one of these equations. Go back here. Every single equation is right here. To find, we start off, pick our initial estimate. Then to find the next number, we just take my initial estimate minus the function at that value divided by the derivative at that value. That gives me my new value. Now to get my next one, I just plug this in and do this again. And then I keep doing this over and over again until I get close enough. And how do I know I'm close enough? I look at the difference between two answers. And when that difference gets close enough, I'm going to say I'm close enough. This is kind of my acceptable error right here. One process is called an iteration when we're doing something like this. So let's look at an example of how this works. Let's get this so I can write on it. So first thing I need to do is get the first derivative. So f prime of x is going to be, 1 minus 2 times derivative of the square root, which is going to be 1/2 times x plus 1 to the negative 1/2 times the derivative of x plus 1, which is 1. We still got to chain rule it. This is a trivial case, but don't forget the chain rule. 2 times 1/2 will cancel out. I get 1 minus 1 over x, the square root of x plus 1. I could make that a common denominator and mess with it, but why bother? That's good enough. Okay. So my idea is I'm going to write down again my formula, which was my next guess is going to be my last guess minus the function at my last guess divided by the derivative at my last guess. So this is what I'm going to have to do. So I come along and let's try to narrow this down a little bit. So I'm going to start with values that are easy to work with. I have a square root, so let's start with f of 0. That's going to be 0 minus 2 times 1 is a negative 2. Let's try 8, because 8 plus 1 is 9. Square root of 9 is 3. 2 times 3 is 6. So 8 minus 6 is 2. So here I got positive and negative. I know there is a 0 between 0 and 8. So I'm going to just start off by guess. So my first guess, again, I'm going to pick something easy to work with. My first guess is x equals 3. I'd find out what's f of 3. F of 3 is -1. F prime of 3 is going to be 5. So my next step, I'm going to get, that's my x sub 1. So x sub 2 is going to be 3 minus a -1 over 5. Okay. Sorry. That's a 0.5. I'm going to say, this doesn't look right. Okay, that's why it doesn't look right. That's going to get my F2 is 5. So I look at the difference. 5 minus 3 equals 2. That's too big of a difference, so I'm not good yet. So I go through and I do this again. So for x3, oh no, let's go back here. So if I have my x of 2 equals 5, I do f of 5 equals 0.10102. F prime of 5 equals 0.5918. And so again, I do, to find my x3, I will get 5 minus 0.10102 divided by 0.5918, and I'm going to get 4.8293. Now I look at the difference between this and this, and I'm looking at a difference of 0.18. 0.17. That's getting much closer. If I go to my next one, if I go 4.8293 minus f of 4.8293, f prime of 4.8293, I'm going to get 4.8284. Now I want a difference less than 0.001. And if I look at the difference between these two, it's going to be 0.0009. So I'm going to say this is the approximation of the zero of this function. So that's Newton's method. I pretty much just wanted to show you this. This is something, again, basically the way technology goes and does that. Your calculator is good at doing these calculations over and over and over again, so it can figure this out. That's what you do if you had to do it by hand, which I'll give you a few problems you can do by hand. I'll probably let you do it on a quiz. Hey! Let's do a few problems over that.